Hey, welcome to Lesson 7 of Module 6, Patterns in Scatter Plots. So in the last lesson, we looked at scatter plots and we talked about whether they appeared to be, whether there appeared to be a correlation between the two variables. Remember, we're talking about bivariate data sets here. So there are two variables plotted on a coordinate grid. And so today we're just going to get a little deeper into these patterns that scatter plots can show. So when you look, we're looking at example 1 now. When you look at a scatter plot, you should ask yourself the following questions. And read along with me in your notes here. Does it look like there is a relationship between the two variables used to make the scatter plot? Okay, and we were asking ourselves that question in the last lesson as well. And second question we should ask ourselves is, if there is a relationship, does it appear to be linear? Okay, because not every relationship will be a line. Some might be a clear pattern in the relationship, but it's curved. If the relationship appears to be linear, is the relationship a positive linear relationship or a negative linear relationship? So positive linear or negative linear. Okay, so to answer the first question, we're going to look for patterns. And we're going to ask ourselves these 3 questions, by the way, on all of the exercises that we do today. So you'll become very familiar with those questions. So we're looking for general patterns. Are the points just scattered on the grid? And if they are just scattered, that would be no correlation, if there's just points all over the place. If you see a pattern, you can answer the second question by thinking about whether the pattern would be well described by a line. And this could be up for discussion, right? This one looks fairly well described as a line. This one down here. Answering the third question requires you to distinguish between a positive linear relationship and a negative linear relationship. So positive linear relationships would have a positive slope. So those would be increasing, like an increasing line, increasing function. A negative linear relationship would be described by a line with a negative slope. Okay. So let's practice on this first one here. So looking at scatter plot 1, I actually have it bigger on this page. Looking at scatter plot 1, we're going to ask ourselves the 3 questions, and here they are. Is there a relationship? Yes, there does appear to be a relationship in this case. If there is a relationship, does it appear to be linear? So this one definitely appears to be linear. We could picture ourselves just coming straight down through this group of points in a line. So the answer to the second question is yes. Okay, so now I can answer the third one. If the relationship appears to be linear, is it positive or negative linear relationship? So we can see this would be a negative slope if we drew a line through it. So this would be a negative linear relationship. Okay, and remember, another way to think about that negative aspect is as the x value or the horizontal axis increases, if it's a positive relationship, then the y values will increase as well. In this case, the x values are increasing, but as they do, the y values decrease. So smaller y values with larger x values. Smaller x values leads to larger y values, because this is a negative linear relationship. All right, so you're going to do that. Go ahead and pause the video and do that for exercises 2 through 5. Answer those 3 questions about the scatter plots that are given. right, so for number 2, I would say yes, there is a relationship and that it does appear to be linear. And if I were to draw a line through these points, could go right through here. And so that would be a positive linear relationship. Okay, so positive linear relationship. Scatter plot 3. Okay, looking at these points here, we've got y values between about 2 and 5.5 is the highest one. X goes from 0 up to, actually there's a y down here at 0 as well. So from 0 to 6, X values go from about 0 up to 5. And there does not appear to be any correlation between these two variables here. They're just scattered all over the place. So I would say does there appear to be a relationship? No. So that means that both of these questions are not applicable because there isn't a relationship. I can't say if it's a line or anything like that. Okay? So scatter plot 3 does not appear to be a relationship. Okay, scatter plot 4. Let's look at this one. This one's interesting. Does there appear to be a relationship? There does. There does. We kind of see a pattern to the data. Kind of useful just to trace out the data, like I'm doing here. So what would we say? There is a relationship. So if there is, does it appear to be linear? No, it really doesn't, because we've got kind of, it's dipping up on this side of 0 and up over here on the positive side of 0. Because notice the x-axis here has negative numbers and positive. So does it appear to be linear? No. Okay, and since it doesn't appear to be linear, then this question is not applicable. Okay. Okay, let's look at scatter plot 5. This one is kind of interesting because at first glance, you might look at it and say there's no relationship. The points are just all over the place. But if you look again and you look closely, you see that in general, there does appear to be a trend kind of going like this. Like as the x's get bigger, we tend to have more points lower. And as the x's are smaller, we have more points that are higher. Okay, so is there a relationship? Yes. But if we compared it to, for instance, this relationship or the first one, it doesn't appear, whoops, I didn't mean to do that. It doesn't appear to be as strong of a relationship. So we could say for number 5, there is a linear relationship, but it's weak, okay? We could say this is a weak linear relationship because it's kind of hard to know even where I would draw my line, somewhere in like that. And if it is a linear relationship, it's going to be negative, right? So we've got, because I was tracing out a negative slope there, negative linear relationship. But it's a very weak correlation. We've got a lot of data points that kind of would lie outside of any line we drew. There'd be a bunch up here and a bunch down here. But still, there is this downward trend in this data, and that's what's important. Okay, so now that you have explored using those 3 questions to analyze a scatter plot, now you're just going to be asked to write a few sentences about each of these. So in exercises 6, 7, 8, and 9, you're going to write a few sentences describing any possible relationship between the 2 variables, between, in this case, it's going to be weight and fuel efficiency. So as you write those sentences, keep in mind the three questions that we talked about. Is there a relationship? If there is it linear? And if it's linear, is it a positive linear or a negative linear relationship? So your answer should include all of that vocabulary. Okay, so go ahead and work independently on exercises 6 through 9. And come back and check them either one at a time or when you're done with all 4 of those problems. Okay, so exercise 6 is a scatter plot of data on weight in pounds and fuel efficiency in miles per gallon for 13 cars. This is similar to one we saw in the last lesson. Using the questions at the beginning of this lesson as a guide, write a few sentences. Okay, so we just talked about that. So what could we say about this one? Okay, so your answer should say something to the effect of, there appears to be a negative linear relationship, because I could draw a line right through this set of points and it would be a negative slope. So there appears to be a negative linear relationship between the weight of a car and the fuel efficiency of that car. And you might even say there's a strong negative linear relationship, because this is a pretty strong pattern. It's not scattered about a lot. It's a pretty strong downward trend there. Something else that would clarify it, the cars with greater weight tend to have less fuel efficiency. Or you could say the higher the weight of a car, the less fuel efficiency it gets, the fewer miles per gallon the car gets. So those are all things that you could have written about this exercise here. All right, let's move on to the next one. Okay, so this is a scatter plot of data on the price in dollars for bike helmets, and we're going to compare the price of the bike helmet to the quality rating for the bike helmet. And we're going to use the questions that we did in exercises 1 through 5 as a guide and write a few sentences. Okay, so what would you say about this? Are we noticing anything as X increases here? We have Y's in all this range, in this from about 30 up to 65. It does not, the price in dollars does not appear to be correlated to a quality rating. Okay, so we could say there does not appear to be a relationship between quality and price of bike helmets in this study. There's no pattern in this scatter plot. Okay, so something to that effect you should have written. Okay, let's look at the next one. Okay, this one is a scatter plot of data on shell length in millimeters for lobsters. Okay, so their shell length and their age. So we're plotting shell lengths anywhere from, it looks like somewhere 60 millimeters up through 160 or something to that effect. And their age, the age of these lobsters goes anywhere from 1 year up to, looks like about 4.5 years right there. So we want to know, is there a correlation between the shell length and the age of the lobster? And so what would you say about this one? Okay, so for this one, I see kind of a curve coming up because it seems to get really steep right through here. And if I try to run a straight line through it, I either miss all these points or I miss a lot of these. So this appears to be a curve that appears to be increasing fairly rapidly here. Okay, so what would we say? There appears to be a relationship between shell length and age in years for lobsters, but it does not appear to be a linear relationship. Okay, but it does definitely as the shell length increases, the age increases as well. But it doesn't, it's not in a linear increase. It accelerates here at the end here. So it's not a constant rate of growth. Okay. Okay, now scatter plot number 9, or exercise 9. This scatter plot is data from crocodiles on body mass in pounds and bite force in pounds. Using the questions, okay, we've already read all that. So we're going to write a few sentences about any possible relationship in this data. So this data, when I look at it, I see a positive linear relationship. Appears to be as body mass increases, the bite force increases. So we could say there appears to be a positive linear relationship between body mass and bite force. Something to that effect. And then to clarify it, as the body mass of the crocodile increases, the bite force increases at a constant rate. Okay, so positive linear relationship. And again, remember, another thing you can put in your description is whether it's a strong relationship or a weaker relationship. This one, let's compare this one to 8. That's a very strong relationship there. That's no relationship. And if you look at 6 is probably a stronger negative linear relationship. And this is probably, number 9 would probably be a weaker positive linear relationship. So because there's more points that would be outside the line that we draw. Okay, let's move to a new topic here. As we're analyzing these scatter plots, as you're looking at a general pattern in a scatter plot, and I'm reading here in your notes, you should also look for other interesting features that could give you clues to the relationship between the two variables. So you want to look for 2 things, clusters and outliers. And those are statistical terms, but they're pretty easy to figure out what they mean, right? So clusters would be places where the data kind of bunches up, like right here is a cluster. I could kind of see a cluster here and one here, okay? So in some of the let's see, here's a plot. This could be thought of maybe as a single cloud of points here in the middle, as opposed to, and this one too, not really clustering. So not every set is going to have clustering. This one looks like there's a cluster right here. So you can look for those clusters, and they can sometimes tell you something about the data if you know what it is that's being measured. Outliers. Outliers are unusual points. They lie outside. That's why they're called outliers. They lie outside of the general pattern of the data or far away from the other points. It's probably a term you've heard before. So let's look at this, this plot below. The scatter plot was constructed using data from a study of Rocky Mountain elk. Estimating elk weight from chest girth, it says. So the variables studied were chest girth in centimeters and weight in kilograms. Okay, so I think everybody knows what weight is. Chest girth you might not be as familiar with, but girth just means how far around. So they would be measuring the elk right around their chest, and measuring it in centimeters all the way around. So let's see, we have some questions here. All right, so exercise 10 asks you to look for any outliers in this data. Okay, so it says, do you notice any point in the scatter plot of elk weight versus chest girth that might be described as an outlier? If so, which one? I would say this point right here. The point that is about, let's write it as an ordered pair, 90, 97, and 100. So a chest girth of 97 and a weight of 100 kilograms appears to be an outlier. If you identified an outlier in exercise 10, I'm looking at 11, write a sentence describing how this data observation differs from the others in the data set. You could say something to the effect of, it describes a much smaller elk than the other data points. And that it's smaller in both, in both weight and chest girth. So it's just quite a bit smaller than that. And let's see. Okay, so this last question asks us, do you notice any clusters in the scatter plot? If so, how would you distinguish between the clusters in terms of chest girth? Can you think of a reason these clusters might have occurred? So let's look back at the data again. So again, when we were talking about it, I was kind of pointing out what I see. There's a cluster there, and then another cluster up here. So we're asked to describe those clusters in terms of chest girth. So what they're asking you is, between what and what data points do these clusters appear? So somewhere in there, and then right here. Drawing the lines down just helps us to read the points. So the first one occurs from about 105, looks like about halfway between 100 and 110. So from 105 to 115. So we could say the first cluster is from a chest girth of 105 to 115 centimeters. Okay, and then we could say the second, I'm just going to get this ready, cluster is from okay, so let's go back and look at that. So the second cluster, it looks like it goes from about 120 up through 145. And I guess it depends if you include these two in the cluster, which the notes include it, so I will too. But it wouldn't be wrong to say that this was a cluster as well. So, so from about 120 up through 145. Okay, and then the last one, the last cluster is from, see what it is, it's from about 155 up to 165, somewhere in there. Yeah. Centimeters chest girth. Okay, so can we think of a reason that these clusters might have occurred? Okay, well, they're all the same species of elk, so we could say that maybe it's different ages of elk. So this cluster here would be younger elk, but it could also be males. Males tend to be much bigger, males and females and younger. So these clusters could be groups in that sense. So if that were true, somebody studying this correlation might want to separate out the younger elk, the females, and the males. But there does still appear to be this positive linear correlation in this data. Okay, so let's just sum up this lesson here. Okay, let's look over the lesson summary to do that. So a scatter plot can show a linear relationship, a nonlinear relationship, or no relationship. And like we said, these relationships can be weak or strong. If it's a linear, it could be a weak linear relationship, or even a weak nonlinear relationship, or a very strong one, where it looks almost like they're just right in a line. A positive linear relationship would be modeled by using a line with a positive slope, and then the negative would be with a negative slope. And then we also talked about in this outliers and clusters. So outliers are points that lie outside of the general pattern, so far away, outliers. And then clusters are groupings. They're like distinct clouds of points instead of one long cloud. It's where the points appear to group up. Okay, and that's why it's so. If you're a person analyzing data, if you're a field biologist or somebody studying a relationship in business or something, putting these things on a scatter plot can make these patterns like clusters and outliers and linear and nonlinear relationships so visible. And give you clues about what you might want to study further. So this is a really, really applicable topic for lots of careers or lots of disciplines. Okay, so good luck with the problem set on this one, and yeah, I think you'll have fun with it. So it's looking for patterns is interesting, and then also just seeing this real data is pretty interesting too, to realize the correlations that occur like this. So, okay, good luck.